All right, before we move on to example 5, let's just kind of summarize what we learned in the last few examples. All right, we looked at both horizontal and vertical shifts. In the last couple of examples, we saw horizontal shifts. So horizontal shifts happen when we change the input. We change the input to the function, right? So if I am inputting x, and then right off the bat I'm taking h away from it, it's going to take more input to get the same output. Okay, and so this shifts it. This is a shift um, shift to it's going to shift it to the right. Right? It's going to shift it in the positive direction because it takes more input to get the same amount of output. All right. If we take an input and add something to it right off the bat, well, it's going to take less input to get the same amount of output. So it's going to shift the graph to the left in the negative direction because it takes less input to achieve the same amount of output if we're adding a constant to it right off the bat. Okay, now a horizontal shift involves a change to the input of the function, and it's called an inside change. Inside change. Right, we're changing the function we're changing the input to the function. Okay, right. Think of the input as being inside the function. All right, so we're changing the input, and it results in a horizontal shift. And it's a little counterintuitive, so you just have to kind of get used to it. All right. We also looked at vertical shifts, the first couple examples, and a vertical shift involves a change to the output. Right, so we're taking the output of the function and adding or subtracting, and it shifts the graph up or down. Now that's considered an outside change, right? Because we're changing the output of the function. And so if we take a function, right, and then take the output of that function and add a constant to it, it's going to shift it up, right? This is a shift up if k is positive. And if we take the output of a function and subtract from it, then it's going to shift it down. Shift it down. All right. So, all right, now that we summarize that, let's go ahead and look at example 5. We're just going to kind of use what we learned. And we're told that the graph of g of x passes through the point 3, negative 4. So what point must be on the graph of g of x plus 6? All right. Well, okay, so if we put in 3, right? So if the input is 3, if x is 3, then g of x is negative 4, and then we're adding 6 to it, right? So negative 4 plus 6 gives us 2. So if 3, negative 4 is on the graph of g of x, then 3, 2 has to be on the graph of g of x plus 6, right? This is just x, and this is g of x plus 6, right? We took the negative 4 and added 2 to it. All right, so let's look at this next one. All right, now we want to find the point that would be on g of x minus 2. All right, so we want we only know the value of the function when 3 is the input, right? So we want this x minus 2 to be equal to 3. So what value of x is going to give us 3? We're just going to add 2 to both sides, so x is equal to 5, right? So if we give the function an input of 5, right, then x minus 2 is 3, and we know what g of 3 is, right? G of 3 is a negative 4. So the point 5, negative 4 is on the graph of g of x minus 2, the g of the quantity x minus 2. All right, the last one we're looking at, we've got a couple transformations going on. We've got both vertical and horizontal transformations. All right, so I only know the value of the function when the input is 3. So I want this x plus 1 to be 3. Okay, so that tells me that x would have to be a 2, right? Because 2 plus 1 is 3. So that tells me that when the input is 2, then I know g of that. Well, then when the input is 2, then x plus 1 is equal to 3, and I know g of 3 is negative 4. But now I'm subtracting 2 from it, right? So my output is now negative 4 minus 2, which is a negative 6. Okay? So if the point 2 comma negative 6 is on the graph of g of x plus 1, that whole thing minus 2. All right. All right. Well, I'll meet you in the next video.